top of the morning to you, and a happy St. Patrick's Day to everyone out there. Good morning. It's St. Patrick's Day, March 17th, 2020. What do we have today? Well, let's see. Student of the day yesterday. Hey, Meal. Nice job, Hey, Meal, for giving me a couple of different extra assignments. Got those graded. Actually, it was maybe from the weekend, but got those graded yesterday. So hopefully those points are in there for you and everything you need. If you need anything, if you want them put in a certain spot, though, you got to tell me, because otherwise I'm just going wherever I think they go. Past assignments here real quick. I do have a call to arms. If you guys can get your elastic constant activity into me, remember those were group activities from the week before we were out of school. Get it in somehow. Either just email it in or post it to Classroom. That'd be fine. I'll take care of it from there. Let's see here. Starting with sound, speed of sound. Speeding of sound going into this week. So I'll be heading into some sound demos over the next couple of days. I do want to wrap up a little bit of waves today. So, investigating pendulums. I posted this as one of our pots in our classes, one of our assignments in our classes. So if you guys can look at that for me, maybe take a few days to see if you can get through investigating pendulums. I'll have a little demonstration for you in just a few minutes. But our question of the day from a couple of nights ago, we had an assignment. Question said something like this. What is the period of a pendulum that is a half a meter long? Okay, what's the period of a pendulum half a meter long? Also, the next question was, what is the period of this pendulum if it's in free fall? What is the period? What you got? What are you doing? What are you doing? What is the period of a pendulum that's in free fall? Okay, so first things first. Let's take the one that's half a meter long. We're going to assume it's on Earth. So we're going to assume it's on Earth. So I'm going to walk you through this real fast. Question of the day. Hang on 1 second. Welcome back, guys. Here I have the period problem on the board here real quick. So question number 30, what is the period of a pendulum that is half a meter long? Well, we're just going to take this period equation. Period equals 2 pi times L divided by G to the 1/2 power, or the square root of L divided by G. L is the length of the pendulum. G is the gravitational interaction of the planet we happen to be standing on. That's Earth today. Anyway, we're going to have 2 pi times the square root of 0.5 meters, that's half a meter, divided by 9.8 meters per second squared. Now when we take this and we divide it and we move the units to the top, don't forget about the units moving to the top. Meters are going to cancel second squared, moves to the top. That's why you're going to get the square root of second squared. And if we take that through a calculator, we're going to get 1.4 seconds. 1.4 seconds. That's a little over a second for a period. And I'll show you this in investigating pendulums in just a few minutes. Now this question of the day. What is the period of a pendulum in a freely falling elevator? In a freely falling elevator, what do we know about G? Well, the system is under free fall. If you'll remember back to our videos from September, October under frame of reference, the force that the falling container cannot exert a force on the pendulum. Therefore, we have no tension in the string. If the string and the container were falling together, then essentially we would have no effective G in an elevator. So a freely falling elevator with no effective G, I guess we'd have 0 in the denominator here, and we would have infinite period, or no swing at all. Sound good? Question of the day? Great. Okay, we're back, guys. This is my homemade pendulum setup. So when you guys get a chance to do yours, I just used a kind of a fireplace holder, tool holder, and just a piece of string and a little metal washer. So for the times that you have to change the mass, you can just add a few things to the washer, maybe just a couple washers. I can paper clip them together, or I can tie them on that, doesn't matter. Or Or if I want to change the length, I can just wrap it around the top part of the holder here. So I'll wrap it around a couple of times. And that changes the length of the pendulum. There's some other things, like you can change the size of the swing. Like if I started swinging here, I'll do a little trial for you. So I'm using my phone as a timer device here. Let's see what I got. There it is. Okay, so I'll try a medium swing here with just this little mass. And I'll go a couple of revolutions. I'll go 10 oscillations. Ready, go. 2, 3, I'll go 5, 4, 5. About 6.98 seconds. All right, so using the same idea, if I wanted to go a little further out, bigger swing, let's see if the size of the swing makes any difference. And go. 1, 2, 3, 4, 5. 7.3 seconds. So 6.9 to 8 seconds to 7.3 seconds. Got a little bit of variance there. I don't know if that is supposed to happen, and that's something for you guys to maybe think about as you complete your investigating pendulum labs. Those will be on Google Classroom, guys, so hopefully you can get that done. Last thing for today, I did find a Google form, or I made a Google form. Maybe you guys can give me a little daily feedback. COVID-19, so we're under strict quarantine, I guess, or social distancing for the COVID-19 virus outbreak. I've got a little over-under Google form. So if you think that we'll be back in school on April 15th, you're going to choose the under for COVID-19. I'm sorry, April 5th. You're choosing the under. That means that we will have less of a severe outbreak and we'll be back before school is scheduled to resume or by school's resumption date on April 5th. If you're taking the over COVID-19, then you're still going to be out a little longer. So that Google form is up on my Google Classroom, guys, if you want to just fill that out. And I'll tally the results and get back with you the next day. Otherwise, tomorrow we'll be talking about sound. I'll do a little recap on some waves. Hopefully you guys can get that elastic constant activity into me. And we'll move on with sound. Got a couple great demos for you coming up this week. So have a great St. Patrick's Day, guys, and we'll talk to you soon.